triangles, we're going to talk about our last concept. And this is 45, 45, 90 triangles. So if we take a square, and I'm going to draw a diagonal across the middle, it actually ends up cutting these angles in half. So, since we know that all the sides of the squares are the same, we're going to call it S and S. And then half of 90 degrees is 45. So this is going to be 45, and this is going to be 45. So let's go ahead and call the hypotenuse H for now. So if I wanted to solve for H, the hypotenuse, I'm going to say S squared plus S squared, right, equals H squared. And you notice this is an isosceles triangle because two of my sides are the same. So when I simplify this, I get 2S squared equals H squared. Then I simply solve for H. So I'm going to go ahead and take the square root of both sides. So S square root of 2, when simplified, is equal to H. Okay, so this is the formula that we're really going to have to memorize for 45, 45, 90. So again, one more time, taking a look, we have S, S, and S square root of 2. Very, very important. Okay, let's take a look at an example. Okay, we're just going to find the missing parts of our triangle here. So if the hypotenuse is S, or is 4, excuse me, I know that I'm going to need to be finding the sides of my 45, 45, 90 triangle. Okay, and if it has a 90-degree angle and it's an isosceles, we automatically know that it's going to be a 45, 45, 90. Okay, so what is the hypotenuse equal to? It's equal to S square root of 2. So we're going to set 4 equal to S square root of 2. So we divide both sides by the square root of 2. And again, we need to rationalize. So we're going to end up with 4 square root of 2 over 2, which simplifies to 2 square root of 2. Okay? So that's going from the hypotenuse to finding the sides of the triangle. And obviously, both sides are equal to 2 square root of 2. Not just one side, but both sides. So 45, 45, 90 are a little bit easier. Okay? And then let's take a look at another problem. This time, I'm going to give you the leg is 8. Okay, if the leg is 8, what does the other leg have to be? It has to be 8. And then our hypotenuse here is S square root of 2. So 8 square root of 2 is our hypotenuse. Okay? So let's try an application problem. So before we did a trapezoid, this time we're going to do a parallelogram. So in our parallelogram, I'm going to tell you that the diagonal here of the parallelogram is 3 feet 6 inches. And the top here is 7 feet 2 inches. And this corner is 45 degrees. That's all we're given. Okay, so the first thing I should do is I need to know what we're trying to find. We're trying to find the area of the parallelogram. Okay, and the equation for the area of a parallelogram is just base times height. And remember that height has to go to a right angle. So it's going to go right here. Okay, so I know the base is 7 feet 2 inches, but we need to have it all in the same units. So I'm going to convert this to inches. So 7 times 12 will give me it in inches. And we get 84. And then I need to add the 2 inches to get 86. So I'm going to do 86 times our height, which we don't know what our height is yet. We need to use our information from our 45, 45, 90 triangle. We're going to be taking a look at this triangle right here. Okay, but I need to convert the 3 feet 6 inches into inches first. So I get 36 plus 6 is 42. So 42 inches, not degrees, is going to be equal to S square root of 2. So when I solve for S here, I'm going to divide by the square root of 2. And remember, we rationalize. So I get 21 square root of 2. So I'm going to go ahead and I'm going to plug that in for my height. So we get approximately 2,554.070 inches squared. Make sure that you're using the appropriate inches. Okay, very important. Okay, so I know it was a lot today. Your homework, if there's time now, you can go ahead and start working on it with your partner. 2, 3, 4, 8, 12, 14, 15, 19, 21, 23, 24, 25, 26, and 27. And if you want to rewatch these videos, I'm going to go ahead and put them on Edline. I hope you all have a great weekend, and I'll see you on Monday.